When we left off, we were trying to understand these vectors that were pointing to the left. We were trying to answer the question, 7 minus 9 equals what? That is, what do we need to add to 9 in order to get 7? We had drawn a number line, drawn in the vector 9 and the vector 7. And we'd discovered, what do we need to add on to the end of 9 in order to get to the end of 7? Well, this odd little vector pointing to the left. If we want to do what we did before and move this little vector to begin at 0, well, 0 can't be by itself at the leftmost edge of the paper anymore. All of a sudden, 0 is right in the middle. So we take this red vector and we move it to begin at 0, and it ends at this point over here. It doesn't have a label yet. In order to label this point, we need to extend our number line off to the left. Our number line has a 1 that's on the left, a 2 that's on the left, 3, 4. In order to distinguish this from the other 1, this from the other 2, this from the other 3, this from the other 4, we call them negative. The numbers that live to the left of 0 and are represented by vectors pointing to the left are called the negative numbers. What we've discovered through all of this exploration is that 7 minus 9 is equal to negative 2, and also that 9 plus negative 2 is equal to 7. Remember the story this came from? Yesterday I had $9. Today I have $7. We've just discovered that the change, or the difference, is negative $2. Note that negative change, then, represents a decrease. When the quantity goes down, we say we saw a negative change. Let's say just a couple words about these vectors pointing to the left. Let's think about negative 5 as a vector and as a point on the number line. Now that we have the negative numbers, remember, 0 has to be in the middle, with the negative numbers going off to the left and the positive numbers going off to the right. So negative 5 is this point on the number line, or the vector that starts at 0 and goes 5 to the left.